Okay, so we are going to discuss this very important topic, counting of figures. This very often figures in most of the important competitive examinations at this level, and most of the students try to mug up some formula to manage counting of figures, but they are usually counterproductive. We rather advise an approach wherein you understand the concept and develop a strategy for counting. Okay, so we will start with this example. So we have to count how many triangles are there. So we will develop a strategy to count the number of triangles. In the first strategy, we will use this vertex here, because we need to understand that for building a triangle or for making a triangle, we need two things. One is, let us say, a base and a vertex that is just opposite to that base, right? And both the endpoints of that base should connect to the vertex, right? So that is the most important thing. So I'll explain again. So the most important thing is that we need to have a base, and both the endpoints of the base should connect to a vertex opposite to it. Fine. So vertex is nothing but a point. So this is what contributes to making a triangle, right? So one of the strategies that we will use here is we can just count the number of angles formed here, right, in this vertex. So if you are able to count the number of possible angles that are formed at this vertex, then we know that for every angle formed, there will be a corresponding base here. For example, if this is the angle, then of course we have a corresponding base at the bottom. You can see that we have a uh, base here that corresponds to that particular angle. So the counting the number of triangle reduces to counting the number of angles here at the vertex. So it's one and the same thing. So the number of angles would be equal to number of triangles. So let us develop a strategy to count the number of angles here, right? So a good strategy would be to realize that to develop or to create an angle, you need two arms, right? So each of these sides that we see here, right, would become an arm for that angle. So if I take the first side, the red one, then there are four options available here with which that particular side can form a triangle. So there are four options: 1, 2, 3, and 4. So there are four options available for this particular site. So I'll write 4 here. And now coming to the next line, this one, the one in yellow that I've drawn here. For this particular side, we will not count the red side because the angle between the red and yellow has already been counted, right? So we will start from uh, here rather. So this is the first possibility, second possibility, and third possibility. So the yellow line can form angles with three sides. So that will be a total of three angles, right? And then we would have another, let us say, uh, a green line here. And this green line can form angles with 1, 2. So two sides, and by the same logic, this particular line can form one angle. So the total number of angles would be 4 plus 3 plus 2 plus 1 equal to 10. So there are 10 possible angles that can be formed at the vertex. So these 10 angles would have a base here, right? So the total number of uh, triangles that can be counted here is 10.